Okay, today we're going to work on some story problems with polynomial equations. Now, the equation you don't have to construct because it's pretty much given to you, and it says on this first one, some of these are easy, others of them are kind of confusing. So, from the years, I'm going to go over the easy ones first and then the confusing ones second. From the years 1987 to 2003, the number of indoor movie screens in the U.S. can be modeled by, then you see this equation here. And you got two variables, you got M and T. M represents the number of movie screens and T represents the number of years since 1987. Find how many movie screens were in the U.S. in the year 2000, okay? All right, so here's what you want to do. You want to copy down the equation since they basically give it to you. M equals negative 11 T to the third plus 267 T squared minus 592T plus 21,600. Now you want to make a side box telling what those variables actually represent. Okay. So M is the movie screens. And it says T's the years, but it says years since 1987. So you need to make sure you got 1987 right there. Okay, so what is my job in the last sentence? This is pretty much all you need on this one. Now you're to find how many screens were in the U.S. in the year 2000. So 2000, put that. And that's a year, so that's like a T, but it says since 1987, so you need to actually subtract 1987 to find the number of years that you're actually going to put into that equation. Whenever that you get that since, yeah, you're going to use a year, but you need to subtract that. And that's going to be 13. Remember, that's going in for T, okay? So I'm going to put those in for T. 13 to the third plus 267, 13 to the second, and then in there too, 592, 13, plus 21,600. Okay, so I'm left with M, and that's just a regular M to the first power, so there's only one solution for M, and you just plug it in there in your calculator. Negative 11, 13 to the third, plus 267, and then 13 to the second, minus 592, and then 13, and then plus 21,600, 34,860. Okay? All right. Let's look at the next one. The weight of an ideal round-cut diamond can be modeled by the equation, and you see the equation. W represents the diamond's weight, and D represents the diameter through the middle of the diamond. What is the weight of a diamond with a diameter of 15 millimeters? So we clearly have an equation that they've created for us. We don't need to create it ourselves like we do with the lines and the parabolas. So that part's nice, 0.48. Okay, now go off this side and make a legend that tells what your definition of the W and D variable is. That says W represents the diamond's weight, and then D represents the, I think it says, okay, I wrote this problem like a moron, okay? D represents the diameter. I didn't tell you, I wrote it like an idiot. Okay, so 15 is the number we get to play with, okay? So 15. Now it's diameter, so it's going in for the D variable, okay? So just plug it in. Okay, so I got W equals 0.0071 times 15 to the third minus 0.09 and then 15 to the second plus 0.48 and then 15. Okay, and that leaves me with W, and it's just W, so there's one answer. So 0.0071 times 15 to the third minus 0.09 times 15 to the second plus 0.48 times 15. Okay. So 10.91, and that's the weight of the diamond, okay? And the diamond's weight is in carats, but since, again, I wasn't very good writing that problem. Okay, from 1980 to 2002, the number of quarterly periodicals published in the U.S. can be modeled by this equation. It's a polynomial equation. P represents the number of periodicals published, and T represents the year since 1980. How many periodicals were in the year 1995? So P equals 0.138 T to the fourth minus 6.24 T to the third plus 86.8 T second minus 239 T plus 1450. Okay, so what do these letters really mean? P and T. Well, it says P is a number of periodicals, and that T is the years, but it's the years since 1980. Okay, so my job is to find the periodicals in 1995. So I put 1995. It's obvious that's a year, so that relates to T. And then I subtract because it's since 1980, so 1980, so that's actually a 15 when I put it in for T. Okay, so I put 15s in for T's. 15 to the fourth minus 6.24, 15 to the third, plus 86.8, and then 15 squared, minus 239, and then 15, and then plus 1450. Okay, and then you go to your calculator, 0.138, and then 15 to the fourth, minus 6.24, and then 15, and then to the third, plus 86.8, 15, and then that's to the second, minus 239, and then 15, and then plus 1450. Okay, so that gives me 3,321 approximately. So P equals only one answer, 3,321. That's how many periodicals were published in that specific year. Okay, now skip over the next couple pages and then go find the next one because the next ones are completely different. Okay, yeah, let's check a look at this one. You have to pause the video to find it. It says from 1990 to 2003, the inland lakes in Michigan. Okay, from 1990 to 2003, the number of inland lakes in Michigan infested with zebra mussels can be modeled by this equation. It just kind of goes all over the place. N's the number of zebra mussels and T's the years since 1990. Find the number of zebra mussels in the inland lakes in Michigan in the year 2000. Okay, so this is me just jotting down the equation. Okay, and then go make a side box, and your variables are N and T. So it says N's the number of zebra mussels, so just put zebra mussels. I don't even know what that is. I'm not a scientist. And T's a year since 1990, so years. And then again, when it gives you that since stuff, you got to take that into account. Okay. So 2000 is what my job to figure out. So 2000, well, that's a year, so it goes in for T. But it's years since 1980, so you got to subtract 1980, and it's actually 20 that's going to be going in for T. So N equals, and then negative 0.028. And then put your 20 in for T. 20 to the fourth plus 0.59 times 20 to the third minus 2.5 times 20 squared plus 8.3 times 20 minus 2.5. Okay, I had to kind of go there. Okay, so negative 0.028 times 20 to the fourth power plus 0.59 times 20 to the third minus 2.5 and then 20 to the second plus 8.3 and then 20 then minus 2.5. Not sure how that happened. I think I wrote okay. Let's just, yeah, I got a, let me try it again. Negative 0.028 and then 20 to the fourth plus 0.59 times 20 to the third minus 2.5 times 20 to the second plus 8.3 times 20 minus 2.5. Nope, I did it right. I obviously wrote a crappy problem, so negative 597 makes 0 sense, but I must have wrote the equation wrong or something, but you get the math behind it. Now pause the video is what I want you to do and go do this problem right here. Okay. Talks about electric vehicles.